Hello everyone. Today we will solve this question. Determine the electron geometry, molecular geometry and idealized bond angle for each molecule. In which case do you expect deviation from idealized bond angles? So before solving this question, we have to understand what is the electron geometry, molecular geometry. So electron geometry is the arrangement of electron groups, while molecular geometry is the arrangement of atoms. It exclude lone pair. After these, we have to understand this table, which gives hint to draw electron geometry and molecular geometry. This table consists of various type of structure which is based on electron arrangement and molecular arrangement with some examples. So learn this table and try to solve these questions. So in NF electron geometry, electron in nitrogen in its outermost shell is 5, and in nitrogen outermost shell contains 7 electrons. So according to Lewis structure, as we can see, electron dot structure which undergo bond formation and make angle between NF is 180 degree. Hence, there are 3 electron domains. Hence, its structure is trigonal planar because of 3 electron domains. And geometry of molecule is linear because of one atom is attached to the central atom, excluding the lone pairs. So, if we will find the structure in above table, we can easily able to understand. So now see the table to find out. Now see in this trigonal planar, so we have 3 electron domains, and we have 3 electron domains. That means what is a structure trigonal planar. In similar way, we can solve all this question. In CH4, valence electron in carbon is 4 electron, and in fluorine atomic number is 9 and it has 7 valence electron. So according to Lewis structure, then we will according to Lewis structure, it undergo bond formation and gives tetrahedral geometry with bond angle 109.5 degree. It means it has electron geometry is tetrahedral, while molecular geometry is also tetrahedral because of it has no lone pairs. So in this way, it has bond angle 109.5 degree, which is idealized bond angle. Similarly, in case of H2S, in H2S, sulfur has atomic number 16, which has valence electron 6 in its outermost shell, and hydrogen has 1 electron in its outermost shell. So according to Lewis structure, these undergo bond formation and make angle 92.1 degree. Because of lone pair repulsion, the angle band, and it gives molecular geometry band type, while electron geometry is tetrahedral because of presence of how many electron domain, that is 4, 1, 2, 3, 4. So it gives tetrahedral geometry. But molecular geometry is what? Molecular geometry is band type because of presence of 2 hydrogen atoms. So it's a simple way. If you learn the table and learn the atomic numbers, you can easily solve this question. As we know, electron repulsion is lone pair repulsion is more. Similar in case OF2. Oxygen has valence electron is 6 and fluorine has 7 electrons in outermost shell. So we will draw a Lewis structure and undergo bond formation. Similarly, it will give band type of molecular geometry. While electron geometry is again same tetrahedral because of four electron domains. An angle between them is 103 degree because of highly lone pair repulsion. Now in second question, we have to find out which species has a smaller bond angle, H3O plus or H2O. So in H3O plus, there's only one. As if we draw structure of these two species, and we can see that H3O plus have one lone pair, while in H2O water molecule has two lone pairs. So there is less repulsion in H3O plus because of lone pair and bond pair interaction. While in water molecule, two lone pairs are present, so it consists of lone pair type of repulsion and lone pair bond pair type of repulsion. So which decreases the bond angles rapidly, and because of more repulsion, hence H2O has a smaller bond angle than H2O. Now next question, we have to explain why CO2 molecule and CCl4 species have non-polar in nature. So in CO2, as we know the structure of CO2 and structure of CCl4, the dipole electron, as we know that oxygen is more negative than carbon, so it attracts the electrons of carbon towards it. So, and we can see dipole moment are in opposite direction. So net dipole moment cancel out. It means zero. So it is no dipole moment is present. That's why it is non-polar. Similarly, in CCl4, both in CCl4 all chlorine atoms are more electronegative and having tetrahedral geometry. So chlorine is more electronegative. It attracts electron from carbon, and both all the dipole moments are in opposite direction. So in opposite direction, the dipole moment cancel out. So net dipole moment is zero. Again, it is non-polar in nature. While there's different case in CH3F. In CH3F, two CH dipole moments cancel out because these are in opposite direction. While one CF and one CH dipole moment towards in same direction, so it adds up and makes some dipole moment. So it makes a dipole moment, hence it is slightly polar in nature. So in this way, CH3CF is different from CCl4 and CO2 molecule. I hope you can understand it.